Good morning, everyone. Thank you for making it to the final day. At every conference, there's a group that makes it to the finish line. And that group is usually the most curious and the most committed. And so today, we hope we can reward that commitment by sharing some insights about Graviton and the latest generation Graviton 5. We look at how the AWS Silicon portfolio has evolved over the years. And then we'll deep dive into Graviton and Graviton 5, which we launched earlier this week. And finally, we'll share with you some best practices, tips, and tricks that can help you in your migration to Graviton. AWS has over 10 years of innovation in its silicon. And in more than 10 years, we have launched 6 generations of Nitro cards, 5 generations of our own custom Graviton chips, and Trainium and Inferentia for machine learning. We have shipped millions of chips across these 3 platforms and seen remarkable success. The question that we get asked is, why Graviton? The main reason is that Graviton delivers the best price performance in EC2. These instances are based on the Graviton chip, which has AWS innovation not only on the chip, but across the entire stack. And that helps us to deliver performance, reliability, and efficiency. There are over 300 Graviton-based instances available in 38 regions worldwide. And that's led over 90,000 customers to use Graviton across a wide array of workloads. And these customers range from small to medium businesses, as well as large enterprises, with verticals ranging from software to financial services, and even media and entertainment. With the launch this week, we now have 5 generations of Graviton that are available. The first generation was Graviton 1. We launched that in 2018 with 16 cores. It was great for scale-out microservices, and it introduced for the first time a low-cost, efficient, and performing chip in EC2. In 2019, we launched Graviton 2, which was a major leap, going to 64 cores, big boosts in memory bandwidth, and it enabled mainstream workloads with up to 40% better price performance compared to other EC2 instances. In 2021, we launched Graviton 3, which was even faster and more efficient. Compute performance increased gen over gen, and we were now seeing customers run compute-bound workloads, memory-bound workloads, containers, Java, and machine learning on Graviton. In 2023, Graviton 4, which increased performance even more for scale-up workloads. So you could bring your large databases, electronic design automation applications over to the Graviton ecosystem. And now we've launched Graviton 5. We'll dive much deeper into Graviton 5 in a few minutes. What's available widely and the latest generation, generally available, is Graviton 4. It's got a huge breadth of instances for compute-intensive workloads, for memory-intensive workloads, and storage-intensive workloads. We have instances that offer 384 to 3 terabytes of memory. These instances also have local storage for your caching workloads, for scratch space. And the I instances include local storage ranging from 45 terabytes to 120 terabytes. If you have workloads that need high-performance network bandwidth, the network-optimized instances offer up to 600 gigabits per second of network bandwidth. And for high EBS performance, we have EBS-optimized instances that give you 720,000 IOPS and 150 gigabits per second of EBS bandwidth. Lots of choice on Graviton 4 available to you today. Let's dive a little bit deeper into what the Graviton server looks like. AWS not only designs the chip, we also design the Nitro SSDs, the Nitro cards, the firmware, the hypervisor that goes into the server. This full ownership across the stack helps us optimize and give you the predictable performance that you expect with reliability, with security, and cost and power efficiency. As a result, what we're seeing is Graviton can now run any workload, whether it's web servers, high-performance computing, electronic design automation, the high core counts that we have, the memory bandwidth, and the custom stack enables all of these applications to run on Graviton and gives you the best price performance overall. It's widely adopted for multiple workloads, including data processing, like Spark, EMR, any C++ applications, workloads like containerized microservices. And we are seeing a lot of our 90,000 customers deploying all of these applications on Graviton today. And here's some of our customers that are really pushing Graviton by running all of their workloads on it and delivering a better experience for their users. For example, on Graviton 4, ClickHouse saw up to a 76% improvement in performance on certain queries. Freshworks experienced 23% improvement in average response time. And Quora saw 20% faster performance on their web servers. And this is just a small set of customers that are running their applications on Graviton 4 today. Another reason that customers select Graviton is to lower their carbon footprint, while also getting the benefit of performance and cost. Adobe saw a 41% reduction in CO2 emissions. JFrog reduced their carbon footprint by 60%. And Snowflake lowered by 57% their carbon emissions per Snowflake virtual warehouse credit. And all of this combined with performance improvements as well as cost efficiencies. We're also seeing customers running machine learning applications on Graviton. Mobileye, for example, experienced a 2x improvement in throughput while driving down cost. And Sprinkler, for their inference and search workload, saw a 30% latency reduction. It's not just our external customers, our own internal customers, which are AWS services, are also rapidly growing their usage on Graviton. For example, over 90% of Redshift serverless runs on Graviton. Managed streaming for Kafka, MSK, Amazon Aurora, RDS, over 60% of all of these services run on Graviton. And overall, across EC2, over 50% of EC2 CPU capacity is Graviton over the last 2 years. Let's now deep dive into Graviton 5. And for that, I'll hand over the mic to Ali.
Thank you, Gautam. So let's talk about Graviton 5. With Graviton 5, we've kind of gone beyond Moore's law. In a single generation, we've doubled the core count, going from 96 cores in Graviton 4 up to 192 cores in Graviton 5. This is a device that's the same size, you put them side by side, as Graviton 4, but now with twice the cores. It's built in a 3-nanometer process, and each core has about 25% higher performance than the previous generation. Let's talk about how we did this. And we're going to start with the cores. We've talked a lot about big workloads and designing for big workloads and how micro benchmarks aren't at all like big workloads. With Graviton 5, we're using ARM's Neoverse v3 core. It's got bigger branch predictors, it can process more instructions every cycle, it can resolve more branches every cycle, and it has larger structures to handle big workloads. It also has more advanced prefetchers, and it's generally a higher performing core. We've coupled that core to our memory system. Deciding what a memory system looks like is always an optimization problem. You'd love to have as much cache as you can, as close to the processor as possible, but that isn't always feasible. You can't make an L1 cache much bigger, just physics. It means you can't access a huge cache in the couple of cycles that you have. With Graviton 4, we increased the size of our L2 caches from 1 megabyte to 2 megabytes. And we saw lots of customers find that it fit their workloads much better and they got higher performance. With Graviton 5, we evaluated where we were going to modify the cache hierarchy. And we decided that it was time to increase the L3 size. So with Graviton 5, we increased the L3 cache by 5.3x. It's now 192 megabytes. And combined with the L2 caches and the other caches in the system, we have over 600 megabytes of cache in total. With Graviton, over the years, we've also led with DDR. Graviton 2 was the first system we had in our fleet with DDR4 3200. Graviton 5 was one of the first servers with DDR5. With Graviton 4, we pushed DDR frequencies. And we're doing that again with Graviton 5. The Graviton 5 CPU supports up to DDR5 8800, and we're working with DRAM vendors to help them qualify DIMMs at those frequencies so that we can use them. In addition, we've worked to reduce memory latency. We've reduced it by about 15% to less than 100 nanoseconds versus Graviton 4. Speaking of I/O, Graviton 5 supports PCIe Gen 6. This is the first CPU in our data centers to support Gen 6. And with it, we have half a terabyte of I/O connectivity. It's going to let us build all the instance shapes and sizes that we've seen with our other compute offerings. With Graviton 4, we had 2 sockets of 96 cores each. Now we put all those cores on one socket. Having 192 cores let us see use cases with scale-up applications like databases, EDA workloads. But the fact that we had 2 sockets and we had the latency between them and we had the limited bandwidth between them meant that some of these workloads couldn't scale as well as we wanted. As we put those 192 cores together in one chip, we've seen up to a 33% reduction in latency. We've seen a massive increase in bandwidth between cores. And we've seen much better scalability for some of these big workloads. We're not getting rid of NUMA though. We're still affinitizing 96 cores to the local cache and local memory controllers to provide better latency and performance. So with Graviton 5, we are announcing our 9th generation of EC2 instances, starting with the M9G instance. They have industry-leading performance, up to 25% better than Graviton 4. Graviton 5 is the most energy-efficient CPU we've built, and it provides the best price performance in EC2, with the same scale-up capabilities, but with lower latency and higher bandwidth than Graviton 4. Now let's spend a bit of time talking about security. There are many things that a hypervisor has to do. It has to do scheduling, it has to do resource allocation, it has to do I/O. When virtualization started, it was all about packing multiple of your workloads together on a server you owned. We've talked over the years at reInvent about how Nitro is different. And with Nitro, we moved networking, storage, and management to dedicated silicon with our Nitro cards. Now, Nitro has many jobs to do, but the most important one is keeping customers isolated. Isolated from each other and isolated from us. With a Nitro system, there's no operator access, and we enforce that with mechanisms, not with just policies. With Graviton, we've been raising the bar on our system security. Graviton 2 was the first system to support DDR encryption. Graviton 4 was the first system we had to support PCI encryption. We took the attestation process that we have in our Nitro cards, and in Graviton 4, we added it to our Graviton CPUs so that we know every chip in our data center is a known production quality device and running the firmware that we expect. And we can continuously measure this through the lifetime of the server. Now, the Nitro hypervisor was purpose-built for one job, and it's an amazing hypervisor. But we constantly ask ourselves, are there opportunities for us to do better? Coupled with Graviton 5, we've also been building another layer of technology to increase the transparency in a virtualization stack, which we call the Nitro Isolation Engine. The Nitro Isolation Engine sits between the Graviton CPU and the Nitro hypervisor. So what is this thing? We're compartmentalizing the most critical elements and interactions between instance memory, devices, and access control into a new layer. There's a couple of really interesting things about this code. First, it's written in Rust, which eliminates a whole class of issues around memory concurrency, or around memory safety and concurrency. But the most innovative and interesting part about the Nitro Isolation Engine is that formal verification was a first-class consideration from the very start of the project through today. When we sat down to start working on the Nitro Isolation Engine, we had software engineers sitting with applied scientists trying to figure out how to formally specify all the interactions within the Nitro system and how we could formally prove those interactions. But you just keep saying formal verification. What does that mean? This is a really simple function. It takes 3 inputs and it produces 1 output. Now, how can you always make sure it does what you expect? Well, you can try different test cases. You can try x is 0, y is 0, z is 0. You can try a few others. But can you exhaustively test this function? It's really simple. It seems like you should be able to, but you can't. Even if you had a processor that could evaluate the result of this function 1 billion times a second, and you had 1 billion such processors, to exhaustively test this simple 3-input function would take more time than the age of the universe. Formal verification instead lets you mathematically show that a function matches the specification that it was intended to implement. And so with this, we can use the application of mathematical logic to reason about systems, particularly what the system can do, what it must do, and what it must never do, for all possible inputs in all reachable states. For a hypervisor, this means we can create and manage VMs. We must preserve guest confidentiality and integrity. And we must never do things like null pointer dereferences or buffer overflows. But critically, for all possible inputs across all hypervisor and guest actions in all reachable states. And so with the Nitro Isolation Engine, we're proving properties that every hypervisor should have, but few can prove that they do have. We're proving memory safety, not just because we're using Rust, but also we can prove unsafe code is also sound. That there aren't any reachable panics, such as unwraps on nuns. That there aren't logical errors, and the specification and the implementation are matching. And that there is confidentiality and integrity of our virtual machines. That there isn't any unauthorized information leakage of VM state. And we're doing this across the core features required to manage the VM lifecycle. We'll only expand this as time goes on. So the Nitro Isolation Engine is embracing formal verification and pioneering a new standard for mathematically proven cloud-based security. And it's the default in our M9G instances. So let's talk now a little bit about designing and building Graviton. When we're looking at building a new version of Graviton, we're bringing lots of workloads to the design process. And one of the ways that we visualize that is these polar plots like this. On the left-hand side are features that tend to be on the front end of the processor, things like branch prediction and instruction misses. And on the right-hand side are things on the back end, things like execution and data cache misses. And if we look at a workload, for example, this is MongoDB running on a Graviton 4, you can see there's lots of instruction misses. There's lots of branch prediction misses and front-end stalls. There's also lots of L2 misses. And so during the design process, we can take a workload like this, and we can ask ourselves, well, how is it going to perform as we're making decisions? But the pre-silicon design process is actually really challenging. There's over a 10,000x slowdown before you have a chip when you're trying to simulate a chip. So running a second of simulation takes hours, and running minutes of simulation can take a month. So what can you do? Over the years, we've developed mechanisms to run workloads in our lab and take state from that and run it in our pre-silicon environment. This is one of the ways we've been collaborating with companies like SAP on HANA and improving performance of the HANA database on new versions of Graviton. But if we go back to Mongo, we can take that shape of what looks like Graviton 4, and we can look at what it's going to look like on Graviton 5. You can see we've reduced many of the parameters here, and we're going to have a lot higher performance. Now, one of the things silicon designers get the most excited about is designing the next version of silicon on the current version of silicon. When we started Graviton, that wasn't an option. But over the years, Graviton has become a big part of the design process, not just for Graviton, but for our Nitro chips and our Trainium chips, with thousands of servers worth of capacity, all being used to develop the next generation. So I'm really excited to announce today that Siemens, which is the maker of one of the most important industry sign-off tools and is used to check that a design is ready for manufacturing, is announcing support of Calibre on Graviton-based processors. This tool is used by the majority of silicon design companies as one of the most critical tools to run fast. Because as fast as you can run it, it means you can iterate faster and you can get to the place where you can tape it out faster. And in their early testing of Graviton 5, they show an additional 30% performance boost on top of the 20% that they saw compared to the other systems that they tested previously. For over a decade, since the inception of Annapurna Labs, Synopsys and AWS have also been collaborating to enable Amazon's custom silicon development. And Synopsys is also expanding tools to support Graviton, including VCS, Primetime, Fusion Compiler, and they've seen substantial improvements in performance here, up to 35% improvements in Fusion Compiler and Primetime, and up to 40% performance improvements in VCS, going from one generation to the next. So while we're on the subject of performance, at the top of this talk, I said 25% performance per vCPU. Let's dive into some of these. Many customers have been doing CPU-based machine learning on Graviton. Gotham shared some information about Sprinkler and Mobileye. And so one of the workloads that we've been looking at with Graviton 5 is, well, how does performance improve with Graviton 5? So we've taken AWS's deep learning containers and run a mix of CPU-based workloads of BERT, Roberta, some image analysis as well. And we see a 35% improvement in performance on PyTorch. We also have many customers who are running Java-based web applications on Graviton. And here too, we're seeing impressive gains. Grails is an open source web framework that uses the Groovy language. And we took a Grails application and fixed a load generator and tried running it on a Graviton 4-based M8G and a Graviton 5-based M9G. And here we see a 32% increase in requests per second. Now, while microservices are great, we also find that monoliths still exist. We don't have a really good open source example of this, but we took an internal workload that's used for delivery planning. And we measured that on Graviton 4 versus Graviton 5. Here, this is a really big workload. It's got a jar that's 100 megabytes or so. And you can see a great 47% performance increase in this case. Nginx is a popular web server. We see it used as a web server and also a load balancer. And here too, we're fixing a load generator, we're fixing a set of web servers, and in the middle, we're either putting a Graviton 4-based M8G or a Graviton 5-based M9G and measuring performance. And here you can see a 27% improvement in performance generation over generation. And lastly, we've seen lots of customers running databases, SQL and non-SQL. And so we took HammerDB. HammerDB is an open source load generator. It's meant to mimic a company that has warehouses, keeps inventory, sells items, and it ultimately produces a score in terms of orders per minute that are fulfilled. And so we took HammerDB and we tried again a Graviton 4-based M8G or a Graviton 5-based M9G to see how they performed. And we saw a 40% increase going to M9G. Now, these are workloads that we've run, but over the last few weeks, we've also had customers running workloads on Graviton themselves. Snowflake has been running their virtual data warehouse on Graviton since Graviton 2. And they recently tried an M9G-based Graviton 5 instance. And they saw more than 30% performance boost on the representative workloads for the virtual data warehouse. Similarly, Honeycomb provides an end-to-end observability platform. And they've also been using Graviton since the M6G was launched in 2020. Out of the box, they see a 20 to 25% improvement in latency. When they tried reducing the amount of compute they needed to keep the latency the same, they saw a 36% better throughput per core. Airbnb has also adopted Graviton. And they tested our M9G instances and said they are some of the fastest instances that they've ever tested and found it to be 25% higher performance than other system architectures. And finally, SAP. We've been collaborating with SAP to support SAP's HANA Cloud now for a couple of generations. And HANA Cloud can do many things, but one of them is online transaction processing. And so in measuring online transaction processing queries, they saw a stunning 35 to 60% performance increase generation over generation. So with this, we have benchmarks we've run that have 27 to 47% better performance improvement. We have benchmarks that customers have run that are so 20 to even up to 60% better performance improvement. Now I'm going to hand it back to Gotham to talk about how you can transition to using Graviton.
Thanks, Ali. That was really exciting. Graviton 5 is we're really excited about what it brings in terms of performance, and it would be great to get your feedback as well once you test it in preview. But now that we know a lot more about Graviton and learned about Graviton 5, I want to take this opportunity to share with you some tips and tricks on how you can simplify your migration to Graviton. Our goal is to make your journey to Graviton as simple and as low risk as possible. And for that, we've learned a lot from our customers running their workloads on Graviton. And we made available best-in-class guides, tools, and resources to help you in your journey. 90% of applications should work on Graviton without code changes. But for the ones that need some work, we have a lot of resources that we can share with you. Let's start with software. If you look at the operating system that are available in the market today, the majority of mainstream Linux operating systems run on Graviton, whether it's commercially available ones like Amazon Linux 2023, Red Hat SUSE, Ubuntu, even community Linux operating systems like Alma Linux and Alpine. All of these operating systems have official ARM64 builds. And these ARM64 builds get regular patches, security updates. And so the OS ecosystem for Graviton is very mature and stable, which means that you can bring your applications to Graviton without any major OS level changes. I mentioned earlier, customers run their containerized microservices on Graviton. For orchestration of these containers, services like Amazon ECS and EKS support Graviton. Docker Hub also allows you to publish multi-architecture images. So you can publish x86 and ARM64 images using these services. You can use Docker BuildX, for example. Graviton also works smoothly with container-optimized Linux distributions like Bottle Rocket. For serverless compute, our services like AWS Lambda and Fargate also support Graviton today. So together, all of these container and serverless products make it really straightforward for you to adopt Graviton across your entire deployment pipeline. You can also use the same CI/CD and automation tools that you rely on today on Graviton. On the fully managed side, for example, services like AWS Code Build, Circle CI, GitHub, they all offer ARM64 environments. So now you can build, test, and deploy applications which are ARM native without managing your own infrastructure. For hybrid models, tools like GitHub Actions, GitLab Runners support Graviton. For self-managed environments, teams can deploy their preferred DevOps stacks like Jenkins agents on Graviton as well. We also have partners that have certified their software on Graviton. And these applications range from observability, databases, security, analytics, and DevOps. And here's a list of some of these key partners. And what this means is that you can run the same commercial software that you run today on Graviton with no functional gaps. We talked about a few of the managed services in AWS. All of these services, DocumentDB, Aurora, RDS, Elasticache, MemoryDB, they support Graviton today. So they offer you Graviton instances for these services. And they manage the infrastructure themselves. So you don't need to worry about that. So using an AWS managed service with Graviton is probably the easiest and most seamless way for you to start using Graviton and deriving those price performance benefits. On the compute side, we talked about ECS and EKS from Amazon, and serverless options like Lambda and Fargate, which also support Graviton. EMR, a big data service, gives you the ability to run your analytics workloads like Spark on Graviton and derive those price performance benefits there as well. Even for machine learning, SageMaker today supports Graviton. And we have customers running SageMaker with Graviton for their inferencing workloads, for example. If you start thinking about what's involved in your transition, there are a few things to keep in mind. And I just wanted to quickly walk you through what those things are, right? The first thing is you want to learn about Graviton. We talked to you about Graviton today, but there's so much more. And we have a great AWS Graviton technical guide on GitHub. It's got a ton of information about what Graviton is, what are the instances, what's the architecture like, and it's got very specific recommendations for each type of workload. So strongly recommend checking that out. Also, if you want to do a free trial, if you want to try Graviton for free, we have a free trial with an EC2 instance called T4G. which will allow you to experience the benefits of Graviton. The second step is to inventory your software stack, right? You want to make sure that you identify all the open source and commercial libraries, all the agents that you're using for monitoring, logging, security, and make sure that they have ARM64 binaries or architecture agnostic code so that you can run it on Graviton as well. If they don't, then you should reach out to the vendor of that software and ask them for a roadmap for when they can support the ARM64 version of that. Or you can reach out to your AWS account team, who can then escalate it to us, and we can try to help. There's also tools like AWS, like Amazon Q Developer, which automates some of this for you. So it helps with version upgrades of Java, for example. Right, so look into some of those tools as well. The third step is to plan your workload transition. When it comes to planning, there's a few things. One is you want to obtain your army, or you want to create a new ARM64 army. You can build or create an image, and we talked about some of the containers support that we have, as well as the image registries. AWS Transform is another great tool which can help you with that. And then you want to test. You want to do some unit and functional testing, right? Make sure that you have the right software versions. AWS Transform is a great resource. We just launched a custom version of AWS Transform on Monday, which has a module which can help with Graviton migrations. It's in early access, but what it does is it can identify incompatible libraries. It can even recompile or upgrade to ARM-compatible versions. It has a lot of powerful capabilities. It's currently in early access, and we're looking to make more enhancements to it. And it's powered by an AI agent behind the scenes, so it learns as you use it and gets better. And then you want to measure performance as well. And we have a tool for that called AWS APerf, which is also available through the GitHub page, the Graviton technical guide that I talked about earlier. And finally, you can deploy. When we talk about deployment, first thing you want to do is update your infrastructure as code. And then you can use the blue-green deployment method, where you can create a parallel Graviton stack next to your existing stack and use weighted routing to send some requests over. And then you can monitor performance and monitor your response times to make sure that the application that's running in production on Graviton is meeting your expectations. Another way to think about the migration to Graviton is you can start with the low-hanging fruit. The easiest and most seamless way, as I mentioned earlier, is to use an AWS managed service, like RDS or Aurora or MemoryDB. EMR is another good one. And all of these already support Graviton, and they manage the Graviton infrastructure. So all you have to do is upgrade to the version that supports it and derive the price performance benefits that Graviton offers. And then there's interpreted languages like Java and PHP and Node.js, which are also relatively easy. All you have to do is select an ARM64 army and install it and containerize the workload to make it even easier. But just make sure you check for certain native modules so that you can upgrade those as well to make sure that it runs smoothly. Compile languages like C and C++ and Python, make sure that those are a little bit more involved, and so you'll have to recompile those and port any intrinsics, assembly, or native modules. And if you have a Microsoft .NET workload based on Windows, you can move that over to a Linux with .NET Core, and then once it's on Linux, you can then migrate it over to Graviton. So there's a spectrum of workloads that you can start with, some a little bit more involved than others. I talked about AWS Custom Transform. This is in early access, the Graviton module, which allows and simplifies the migration to Graviton. For example, for Java. Many Java applications can run on Graviton already because Java bytecode is architecture independent. But if you still have concerns, or if you have native libraries or architecture-specific code, this agent can help you. For example, if there are some shared libraries which have no ARM64 variant, or JNI bindings compiled for x86, this agent will recompile from source code if that's available, or it'll prompt you to ask for an ARM64 compatible version. There's a great dashboard called the Graviton Savings Dashboard. What this helps you with is to calculate the savings that you're getting today from using Graviton, or you can even simulate a workload that's not running on Graviton today and calculate the savings that you might get from migrating that to Graviton. So this is another great dashboard that you can use to justify the migration. Let's look at some very specific workloads. And I just wanted to call out a few key points here. Like, we talked about Spark. Spark is a popular data processing framework. But sometimes it can suffer from straggler issues, where a long-running task can slow down the entire cluster. And this is often caused by uneven data distribution. And so we have some key recommendations. For example, set the shuffle partition size to less than 200 MB. Also, make sure to benchmark and optimize settings, because we've seen up to 80% performance improvement if you do that. EMR, which is an Amazon service where you can run your Spark workloads, that's an option, but make sure to use default settings that EMR provides. As I mentioned earlier, the versions, it's always the best practice to make sure that your versions are the most up-to-date, because we've seen in the case of Spark, you can get up to 40% better performance with Spark 3 and Java 17 compared to Spark 2 with Java 8. So just upgrading the versions can really benefit performance. C++ and C perform really well on Graviton, as long as you compile natively for ARM64. And also make sure to use ARM-specific flags that I've called out here on the slide. Rebuilding native libraries, avoiding x86-specific code, and leveraging vectorization like SVE will greatly help you in running these kinds of applications on Graviton. Python, a high-level interpreted language, runs really well on Graviton when you use ARM64 native Python libraries. Also make sure that your Python math libraries are ARM optimized. We talked about containers earlier. They can help you build and publish multi-architecture container images. The key is to build ARM64 native images. You can also use Docker buildx to build those multi-architecture builds. And here again, verify all the dependencies and make sure that they support ARM64. Java runs very efficiently on Graviton. Just make sure to rebuild any native libraries for ARM and use the latest JDK. The one thing to keep in mind is Graviton gives you very good performance even at high CPU utilization. And so make sure to run Graviton hotter than you normally do with other architectures. Machine learning. We're seeing a lot of customers use Graviton for machine learning, specifically for use cases like automated speech recognition. sentiment analysis, recommendation systems, chatbots. Just make sure to use the right ARM64 native machine learning frameworks, the versions that we've called out here. We also have software abstractions to make it simpler, like AWS deep learning containers. And finally, we just wanted to give you a list of all of the resources that are available to you. The first one I mentioned is the AWS Graviton Technical Guide. The link's on here. It's got a wealth of information to help you with migrating any workload over to Graviton, and it's continuously updated. We also have migration resources. If you want to do a free trial, the T4G instance offers you a free trial of Graviton. Tools like AWS Q Developer, AWS Transform, they're available today, so definitely take advantage of that. And the Graviton Savings Dashboard as well, to calculate your savings. APerf, which is a tool built by us, which collects performance metrics during your migration and helps you to analyze those metrics to optimize performance on Graviton. So, get started today. And the biggest thing to keep in mind here is the reason that you're looking at Graviton is because it delivers the best price performance across any EC2 instance. Also, the Graviton 5-based M9G instance is available today. It's in preview. There's a preview form on our website where you can go and sign up for the preview. And as our VP, Dave Brown, said, all it takes is 1 week, one application, and one engineer, and you'll be surprised by what you can do in migrating your applications to Graviton. Thank you for your time. I appreciate you all being here.